Hi guys, welcome back to my channel. Today let's do another challenging problem. So the problem reads, you have a table that tells you depth and pressure. And then the question stem reads, the table above gives pressure measured at various depths below the surface of a liquid in a container. A second liquid whose density is twice that of the first liquid is poured into a second container. Similar pressure measurements are taken for the second liquid at various depths below the surface of the second liquid. What is the pressure at a depth of 10 centimeter for the second liquid? Okay, you're welcome to pause the video and give it a try. Otherwise, we're going to dive into this. So this question for students usually takes about 3 to 5 minutes to solve on MCAT if they know how to solve it. But today, after we go through the complicated, the traditional, formal, nitty-gritty computation, the next time you'll be able to really just do it in 5 seconds, okay? All right. So let's break down the question, all right? And we're going to go through the detailed steps of solving this before we learn the trick, okay? All right. So the first sentence says, the table above gives pressure measured at various depths below the surface of a liquid in a container. Okay, it's a long sentence, but I know I have a container and I have some liquid in there, right? And then it gives me different depth, right? This is 5 centimeter, this is 10 centimeter, this is 15 centimeter, okay? And then I know that I'm measuring the pressure at different depths, right? So the pressure is the dependent variable of this experiment, what I'm measuring for, right? And then the different depth is really something I get to manipulate, right? I get to choose. So that's the independent variable of this experiment, right? I mean, it's not very important for you to know this for this question, but you just need this MCAT intuition. Whenever you read something, right away, it's like a second nature for you to know, oh, okay, pressure is the thing they're measuring, it's dependent variable, and then the different depth is the independent variable, okay? All right, let's keep reading. A second liquid whose density is twice that of the first liquid is poured into a second container. Okay, I have a second container, I have a different liquid, right? Why is it different? Because the second liquid density is twice that of the first liquid, okay? So if the first liquid, I have a density of a row 1, let's say, and then the second liquid will have a 2 row 1. That's the density of the second liquid, right? Okay, that's it. That's all the first 2 sentences tell me, okay? I don't know what is the density. I don't know what kind of liquids they are, but I just know that this relationship, that twice, okay? All right, and then the question says, similar pressure measurements are taken for the second liquid at various depths below the surface of the second liquid. Okay, so this is basically tell me for this second setup, I have the same thing that I'm measuring. I'm measuring what? Pressure, right? And then I'm also measuring this at different depths. So very similar, exact same setup, I mean, as the first setup, right? Okay. Then the question asks, what is the pressure at the depth of 10 centimeter for the second liquid? Okay, so at a 10 centimeter depth, if you were to measure the pressure, what would you get? A, B, C, D, okay? So how would you solve it? Do you have a clue how to solve it, right? Okay, so before we dive into the equation, the computation, I want to ask you, what is this pressure referring to? What does that refer to? What does it mean? I'm not looking for an answer that, oh, pressure is a force over area, because that the unit tells you, right? Of course, it's force over area. But I'm asking, what kind of pressure is this pressure referring to? How many components of this pressure do we have, right? Okay, so if you know the answer, you will be saying absolute pressure. Okay, so this purple pressure that I highlighted, the thing that we're measuring is really the absolute pressure, right? And then the absolute pressure contains 2 components. One is the atmospheric pressure, right? I'll say PATM, okay? Let's say sea level pressure. What is the atmospheric pressure? 1 ATM, right? Okay. All right. Plus P gauge. Okay, you might be wondering, what is gauge pressure, right? So in our case, let's say, so at this 5 centimeter depth, you have that much liquid above it, right? So the gauge pressure, this depth feels is really the force exerted by those liquid over a certain area, right? Okay, so that's what gauge pressure is, right? If you are at a different level, let's say 10 centimeters, you have a more liquid on top of it, right? So you will, of course, have more force that's being exerted on this depth, and thus more pressure, right? Because the cross-section area is all the way through, right? It's this same. Okay, so as you see, as my depth goes deeper and deeper, I have a higher and higher pressure. That makes sense, right? More stuff on top of it, more pressure that the certain depth can feel. Okay, all right. So that's it. Okay, so that's the gauge pressure. Okay, and then so to solve, so you may be wondering, some very smart people will say, okay, so I need to know at this point what is the gauge pressure and plus the ATM, PATM, I'll know the answer, right? Yeah, that's exactly right. And then the equation for solving this gauge pressure is really this rho, so whatever the density that has, or you can say it's P rho 1, okay, that's the rho 2, okay, times what? G. G is the gravitational constant 10, right? On MCAT 10, usually it's 9.8 on our physics exams, but it's 10 on MCAT, and then H, right? H is really the depth in this case. Okay, so that I know that the question asks me 10 centimeters. So I can plug in this H. I can say 10 centimeter, which is 0.1 meter, right? I can really plug in the H. And then G, I know it's 10. But what is this, right? What is the density? I don't know. And what is this that I don't know, right? But you can really solve these two variables according to the table, right? Okay, because that we know the PATM is constant for any point A, point B, point C, point D, point E, point F. Any point in any of these are liquids, right? It's not that I'm putting one container on sea level, another one on top of a high mountain, that they have super different atmospheric pressure, right? They have the same, they're close to each other, they have the same PATM, right? So that I know this. And then I also know that if I can know the density of the first liquid, then I'll know the density of the second liquid, given this twice relationship, so that I can compute this, right? Okay. All right, so then how do we figure out the PATM? Then we know that, okay, 250, that's the pressure. It's also from PATM, this constant PATM, plus whatever rho 1 is, times 10, times 5 centimeters, right? Okay, so 5 centimeters or 0.05 meter, okay? All right, so you're like, okay, now I still don't know, because this is a known, how am I going to solve it, right? You just write out another equation, right? 450 equals what? Equals still the same PATM plus what? The same density, right? Times 10, and then what? This time is a 10 centimeters, so it's a 0.1 meter. Okay, so see, now you can solve it. You can use algebra, right? Let's say this is equation A, this is equation B, and then you can really equation B minus equation A, and then you can cancel out these, and then figure out the density, and then you plug in the density, you figure out the PATM, right? Does that make sense? And then you can, okay, plug the same ATM to this equation, and then you double the density, and then you know this, and then you're like, voila, okay? Yes, that can lead you to the correct answer, but that takes 3 to 5 minutes, okay? So let me just teach you a tricky way, sneaky way to solve it in 5 seconds, okay? Okay. Let me clean it up a little bit, so that you have time to breathe, as I know I'm a fast talker. Sometimes people wonder if I talk even faster in my first language. I'll say about the same. Okay, so how do we solve this in a sneaky way? Okay, so as you know, this pressure contains this absolute pressure contains the atmospheric pressure and the gauge pressure, right? And then you notice that as I times 2, as I double my depth, right? Okay, this is not totally doubled, right? If I go from 200 to 400, then it's totally doubled, right? But not in this case. And then you notice that 5 to 15, that's like you times 3, right? It's 3 times. But 200 to 650, it's like 200 to 600, you realize, okay, that's times 3. But this 50 is just annoying, which means what? It means 50 is a constant, which is the atmospheric pressure that's in the way, okay? If I only just have this gauge pressure, it should line up, right? When you go from 5 to 10, you should go from 200 to 400 or 250 to 500. Yeah, that's logical. But you know that this 550 is in the way, right? So it is my atmospheric pressure. So okay, so I know right away it is 50, okay? Whatever the unit is, okay? So that's 50. Okay, that I know. Okay, now I need to solve what? I need to know this gauge pressure, right? And then gauge pressure, you know that at 10 centimeter, let me use a different color. So at this 10 centimeter, I have a, how many? I have a 400 pressure, right? That is for my what? For my liquid one with my density of rho 1, right? But the second liquid, it's also the H is still the same. H is still 10, right? H is still 10 for my second container. And then G is still the same, the 10. But what? But my density really doubled, which means my gauge pressure is doubled, right? So the gauge pressure of liquid 1 is what? 400. And if I were to double it, it's 800, right? So that's after I double the gauge pressure. That's the gauge pressure that's felt by the second container at the 10 centimeter depth, right? So you just 50 plus 800. See, voila. That's a real voila, okay? All right, so I hope you get it. If you don't, that's totally fine. It's really challenging. You can keep watching this video, and I'm confident that it's gonna click, okay? All right, so yeah, I hope that's helpful. If you guys have any challenging questions that you want me to solve, see how I can solve them in a couple seconds, you're welcome to leave a comment and let me know. I hope that's helpful.